Hi, I'm Dave Farina. In today's lecture, we're going to be discussing Chapter 0, Charting the Heavens, specifically Part 5, Science and the Scientific Method. The scientific method is a very important process, and it's the process that is meant to keep scientists from making decisions based on hunches and to keep science as completely objective as possible. In order for scientific theories to be generated, the idea must be testable. We cannot just come up with ideas that we think are going to happen or that we want to happen. They have to be testable. Furthermore, scientific methods require that we continuously try to test and break our ideas. We want to try to see where our mistakes are being made so that we can improve upon our theories. Third, it really should be simple. The old saying, "keep it simple, stupid," is not something that scientists were thinking of, but it happens that the most elegant of theories are often the most simple. And the last one, as I said already, it should be elegant. It should just work so well, and in the end, you find that the more simple and the more elegant theories are, the more correct they generally become. Scientific theories can, in fact, be proven wrong, but they cannot ever be proven 100% right with 100% certainty because we're always pulling in new information. That does not necessarily mean that they are not a valid piece of evidence. In fact, scientific theories are by far the most strongly supported ideas and facts that we have because of the amount of testing that's being done, because of the amount of peer review that is required in the scientific community. Our ideas, our theories are put to the test. So the next time someone says to you, "That's just a theory," say thanks. That's the most important and most proven ideas that we have. Now, the scientific method is sometimes portrayed as some sort of step-by-step process. I want to break that idea for you today. The scientific method is definitely going to benefit from going through all of the processes involved. Things like observation is absolutely required. Predictions are oftentimes made, but sometimes scientists don't necessarily predict anything. They might make a mistake that they stumble upon, and they observe something, and with their keen scientific senses are able to pick up on something that doesn't quite seem right, or they can't find an explanation for. So try not to think of the scientific method as some sort of rigorous, directly step-by-step process that oftentimes is portrayed in school. We don't necessarily always plan for things to occur, and sometimes the best science is by mistake. Finally, a brief summary of this chapter. We talked about scale. We talked about our place in the universe. We've talked about how seasons can change as a result of the varying amounts of sunlight and sun angles that we receive. We've discussed how the moonlight is being changed by its trip around the Earth, and the Earth and the moon's trip around the sun to create our phases of the moon. We've talked about eclipses, both lunar and solar, and how these lunar and solar eclipses don't always happen due to the tilt of the moon's orbit compared to the ecliptic. And finally, how the solar day and sidereal day are not the same, and how the sidereal day is shorter than the solar day because of Earth's motion around the sun and the resulting catching up that we have to do to get back to that original position with respect to the sun due to that motion. So hopefully through our videos in Chapter 0, you're able to have a better appreciation for astronomy, and that by chapter 1, you're ready to go. And I hope you enjoyed the video. Thank you. Have a good rest of your day.